Today let's look at adding and subtracting radicals. So as a reminder, when we add and subtract terms like monomial terms, we can only combine like terms. For example, something with an x can be combined, added, or subtracted to something else with an x. 7x plus 9x simplifies to 16x. When we have a different term with a different variable, 5y, that must stay as a separate term. We're going to use that same concept when adding and subtracting radical terms. We can only add or subtract terms with the same radical. In this example, if we replace that x with the square root of 2, we can see that we have two radical terms that both have a square root of 2. This allows us to add their coefficients the same way, and they combine to 16 root 2. If we have a different radical, like 5 root 3, that must stay as a separate term because it is not a like radical term. Let's try an example of that. So in this example, we're going to simplify 4 different radical terms, and we're going to look for any like radicals. For example, having a root 11 and a minus 5 root 11. Both having the square root of 11 makes those like terms. If there's no coefficient in front, what number do we presume is there? Yes, 1. So we'll do 1 minus 5, giving us a coefficient of negative 4 and then root 11. We can do something similar with our other two terms since they're both have a root 13. We have minus 8 root 13 and minus 8 root 13. We combine the coefficients and get minus 16 root 13. And as neither of those radicals can be simplified further, that's actually as simplified as we can get. Let's take a look at another example where we do have to simplify our individual radicals. So for this example, we have 3 different radical terms, and on first glance, it looks like we cannot combine them. Let's take a look at some of these radical terms separately and see what we can simplify. We cannot simplify the root 5, but we can simplify the square root of 20. That is equal to the square root of 4 times the square root of 5, and that is just 2 root 5. When we get more comfortable with radicals, you can probably do that all in one step. Let's do something for the root 45 as well. Find two numbers that multiply to 45, like 9 times 5. So this is the square root of 9 times the square root of 5, or 3 root 5. Now we actually have 2 more radical terms that have a root 5 in them, so let's rewrite. So we start off with root 5. Instead of plus root 20, we can put in our 2 root 5. So plus 2 root 5. And then instead of minus root 45, that's minus 3 root 5. At this point, all 3 of our terms are like radicals, so we can go ahead and combine them. We have a coefficient of 1 there, even though we usually don't write it in. So we have 1 plus 2 minus 3. That is 0 root 5. And of course, 0 times anything is just going to be 0. This would be a good time for you to try the next one, so you can pause the video, try to do the next one by simplifying the individual radicals, and then come back and check. Okay, let's do the same thing we did last time and simplify the radicals off on the side first. So I'm going to start with just the radical parts and simplify those. For example, well, we can't really do anything with the root 6, but we can with the root 12. The square root of 12 is equal to 2 root 3. And you might notice we don't just have the square root of 12, we have minus 5 times the square root of 12. Negative 5 root 12 should be 5 times whatever root 12 is equal to, or negative 5 times 2 root 3. So this is actually going to be negative 10 root 3. And let's rewrite this underneath. 8 root 6 minus 10 root 3. And let's do the same thing with our third term. So we have a square root of 27. The square root of 27 is equal to 3 root 3. But we actually have 2 root 27. So if we multiply our previous expression by 2, it's 6 root 3. And we put that back into our longer expression, plus 6 root 3. Now we look for any like radicals that we can combine. So we still have a root 6 that will not combine with the other terms, but both of the other radicals have a root 3. So these are the terms that we can combine when simplifying. So we leave the 8 root 6 in front, and then we combine our coefficients. Negative 10 plus 6 is minus 4 root 3, and this is our simplified version. We can also apply the same concept even if we have roots that are not square roots. Let's take a look at one example where we have cube roots and try the same thing. So I'm going to come off to the side and simplify the cube roots the same way, just the cube root. So the cube root of 16, we want to factor this into two factors so that one of our factors is a perfect cube. So I'm going to do the cube root of 8 times the cube root of 2, which is 2 times the cube root of 2. And let's do the other radical while we're at it. The other one is the cube root of 54. So we want two factors so that one of those is a perfect cube, and 27 works really nicely for that. So the cube root of 27 times the cube root of 2. And this is 3 times the cube root of 2. Now let's put both of these back into our original expression, but let's put those coefficients back in. So we actually started with a 4, and then instead of the cube root of 16, I will put in brackets that is equivalent to 2 times the cube root of 2. And then for our second term, plus 3. And instead of the cube root of 54, I will replace that with 3 times the cube root of 2. I'm trying to be a little bit careful with the brackets here just because I do have a coefficient and I'm going to need to multiply it with another coefficient. So multiplying our coefficients, 4 times 2 is 8 times the cube root of 2, plus 3 times 3, which is 9 times the cube root of 2. I'm just going to come back and fix that root so it extends over the 2 like it should. And now that we have our like radical terms, we can combine the coefficients. 8 plus 9 is 17. So our simplified version is 17 times the cube root of 2. And that is our fully simplified answer. All right, and that's all for today.